Welcome to Atomic Bonding, Part 1. We know of 119 elements, but there are so many more things in our universe than just those 119 elements. These elements combine with each other in countless ways to create new molecules and compounds that have unique properties. Compounds, particles made of more than one type of element, and molecules, particles made up of more than one atom, can have properties that are totally different from their component elements, making possible the extensive variety of things we see in our universe. Elements join together by forming bonds. They do this in order to become more stable. Atoms are the most stable when they have a full outer energy level, like the noble gases have, meaning they want to have 8 electrons, as this is considered full in terms of outermost or valence energy levels. If an atom doesn't have a full outer level on its own, it will form bonds with other atoms in order to get that full outer electron level. These bonds are a little different depending on which types of elements are bonding together. Covalent bonds happen between two nonmetals. Ionic bonds happen between a metal and a nonmetal, and metallic bonds happen between metals. We put elements into one of 3 major categories: metals, metalloids, and nonmetals. Today we are just going to focus on metals and nonmetals and how elements from those 2 categories interact. Metals are usually hard and shiny. They are good conductors of heat and electricity, and they have lower electronegativities and ionization energies. Nonmetals can be solids, liquids, or gases. They are brittle if solid and can be quite colorful. They are poor conductors of heat and electricity and have high electronegativities and ionization energies. Remember, electronegativity and ionization energy both have to do with how good of a pull or hold an atom has on its electrons. The higher electronegativity or the higher ionization energy an element has, the more likely it is to attract electrons from other atoms and to hold on to its own. The lower the ionization energy and electronegativity, the less likely an atom is to hold on to its electrons, and more likely it is to give them away, or lose them, or get them stolen. You get it. When metals and nonmetals get together, they create something called an ionic bond. Metals have only a weak hold on their outermost or valence electrons, and so readily give up one or more to become positive ions. Nonmetals love their electrons and want more electrons. These traits determine how these elements form bonds. When metals bond with nonmetals, the metals give up electrons to become positive ions. These electrons can then be taken up by the nonmetal atoms, making them into negative ions. And you know what they say about opposites, right? They attract. Because metals and nonmetals form oppositely charged ions, they are attracted to each other, forming what is called an ionic bond. When the bond is formed, the charges cancel each other out, making a compound that has a total charge of 0, even though it's made of charged components. As we see with the ionic bond between the beryllium and oxygen ions, the charge of the ions involved can be more than 2. However, they have to cancel out. They have to have a net charge of 0, even if that means that there's more than 2 ions involved. There are a lot of substances that you see all the time that are held together using ionic bonds. Salt is made up of sodium and chlorine ions that are bonded together ionically. Also, the rust on metal is made with ionic bonds between oxygen and whatever metal is rusting, usually iron. And that's all for this week. Next week we'll continue with covalent and metallic bonds. And so, the end.